Welcome to Seymour Wind Farm. I'm Scott Mackenzie, Head of Wind Operations with Infinis. Seymour Wind Farm is located between the villages of Seymour and Hilton, 5 miles south of Middlesbrough. The turbines are on either side of the road that connects both villages, making the wind farm very much part of the local community. Infinis are a generator of only renewable energy. We operate a portfolio of wind, hydro and landfill gas generators across the UK. We have 16 wind farms throughout the UK, of which Seymour is one. In total, we have 273 megawatts of generating capacity. Seymour is one of our newest sites. We acquired the site during 2012 from the previous developer. The site is one of our best generating wind farms, and we are very proud to have it as part of the Hilton and Seymour community.
There are 5 wind turbines at Seymour. In the last operating year, they generated 34,800 megawatt hours of power. That's enough electricity for 8,300 homes a year. To give this number some perspective, if a low-energy light bulb of 25 watts is switched on for 1 hour, it would use 25 watt-hours. That's 25 watts for 1 hour. 1,000 watts is a kilowatt, and 1 million watts is a megawatt. This is how energy is measured and metered. Seymour Wind Farm contributed to reducing the carbon emissions of the UK by 15,000 tonnes during the last operating year. The UK is considered to be one of the best locations for wind power in the world, blessed with 40% of Europe's wind resource. Within the UK, the northeast of England is one of the best locations for wind power. Wind resource is a key consideration for the location of turbines, but it is not the only consideration. Great care is taken, working within planning guidelines and industry best practice, to ensure wind farms are, for example, located away from migratory bird routes. The planning process is extensive, and a full environmental impact statement is produced prior to planning permission being sought.
The turbines here at Seymour will operate on most days of the year and will be turning at least 80% of the time. Whenever the wind speed gets up above 3 metres a second, that's a light breeze, the turbines will commence operation. The amount of power produced then varies from 0 megawatts up to the maximum of 2 megawatts. This is dependent on the strength and consistency of wind.
My name's Paul Prescott-Clements. I'm the wind farm manager here at Seymour. My primary role here is to make sure that the site operates as efficiently as possible, making best use of available wind, so we schedule work where we can around the wind speeds. However, our primary focus is the health and safety of our technicians that work on this site, and we carry that out through a work management process and a work control system which we operate through our logistics centre. Seymour Wind Farm is one of our more efficient sites, and we see very good availability at this site, and that's partly due to the efficiency of our technicians.
The wind farm is connected to a local electricity distribution substation. When the wind farm is generating high levels of electricity and local consumption is low, this substation will be exporting power to the wider network in the local area. This means that instead of pulling power from the national grid, power that is generated by coal and gas is displaced. At these times, the homes and businesses of local people are being powered from the clean, renewable power generated at Seymour. Using the wind for energy is nothing new. Windmills have been in use since 2000 BC and were first developed by the Persians and Chinese. The Tibetans have been using wind to power prayer wheels since the 4th century. Britain's oldest working windmill is Outwood Windmill in Surrey and dates from 1665. Records show Teesside had at least 9 working windmills, some of which are still standing, although no longer in use. We all understand that we have to find sustainable, clean ways of generating power, and sites like this one at Seymour are doing just that. The UK has a legally binding target to source 15% of our electricity from renewable energy sources by 2020. Increasing the use of renewable energy has a number of benefits. Greenhouse gas emissions are reduced as less coal and gas is burned. Less coal and gas is imported to the UK, increasing our ability to meet our own energy needs. As coal and gas prices are expected to increase in future years, renewable fuels such as wind, sun and water always remain free and never run out.
I'm David Mahal, Regional Operations Manager for Wind South and Hydro. December 2013 was a record-breaking month for wind power, generating over 18 million megawatt hours, which was 10% of the UK's power demand. In addition, on 17th of August, wind power contributed over 22% of the UK's power demand. Wind power is a significant contributor in the green supply of energy for the UK.
Whenever there is a sustained light breeze, the turbines turn on automatically, and they can be shut down individually for maintenance. Each one operates independently, dependent on the wind conditions it is experiencing. So don't be surprised to see one working whilst the neighbouring turbine is still. The turbines turn to point into the wind. This is called yawing into the wind. The angle of the blades changes to get the maximum amount of lift from the wind. This is called pitch. Let's take a closer look at the wind turbine.
The 80-metre turbine tower is made of 3 tubular steel sections stacked together. These are bolted together using 350 bolts. Each bolt is checked and tightened regularly. On top of the tower is the nacelle, which houses the generator. Nacelle is the name given to the engine housing on an aircraft, typically slung under the wing. This is why it was used in the wind industry. The nacelle can rotate on top of the tower to face into or out of the wind as desired. At the front of the nacelle is the rotor. The rotor consists of 3 45-metre blades. Each blade is half the length of a football pitch. Attached to the central hub, creating a 3-bladed rotor with a 92-metre diameter designed to catch the wind. So that's the basics of the external structure, but what goes on inside the turbines themselves?
Wind turbines are very reliable and are typically expected to be available to generate power, wind permitting, 98% of the time. As a result, Seamer Wind Farm is not staffed permanently, but run remotely via a computer from the Infinis control room that operates 24 hours a day, all year round. This means very little activity or traffic on the site other than planned visits from engineers and occasional unscheduled visits to fix breakdowns. Each turbine on the site is checked monthly. The engineers enter the turbine on the access deck.
We're at the access level of the turbine now. Inside here we have high voltage switchgear. We have large cables coming down from the generator upstairs. It generates at 690 volts. That goes into a transformer on the deck below me here, and then into the high voltage switchgear and out for distribution onto the network at 33 kV. Okay, I'm going to head upstairs now. Okay, here we find ourselves at the control level of the turbine. This is the local controller, the local computer. So the local computer looks at wind speed and direction. It can control the power of the machine and its direction to maximise output. We can think about the turbine as a whole as a complex computer with some less complex mechanical components around it. This is the heart of the beast. So this is the third level up in the turbine now, at the lift level. Obviously it's still a long way to the top, so to make it easier for the engineers, we've installed lifts in these turbines. So anyone working and operating in the wind turbine has to have a 3-day climbing course specifically designed for wind turbines, which includes emergency rescue and evacuation techniques.
So we are on what is called the yaw deck. Unlike original windmills, wind turbines are able to turn into the wind or yaw into the wind, which means they're facing directly into the wind. The wind will pass over the blades, creating lift, enabling the turbine to create electricity. As you'll see, there are multiple brake calipers around, holding onto the brake disc. At this section here, the tower joins the nacelle, the large box at the top of the turbine, and it is able to yaw into the wind. What enables it to yaw into the wind is the Met instruments on the roof of the nacelle. That tells the turbine which direction it's facing and the wind speeds. Some people think there is quite a complicated mechanism of getting the power from the generator down to the bottom controller and the converters. In fact, it's quite simple. The LV cables come out the back of the generator, go down to the converter and into the switchgear. From there, it goes out to the national grid. The LV cables are looped, which enables the turbine to turn complete 360 degrees 3 times. At that point, the turbine recognises that it has reached 3 turns, will stop and automatically rewind to prevent any damage to the cables and the turbine. So if you see a turbine turning round instead of yawing backwards and forwards into the wind, that's what it's doing a cable unwind. Okay, we've now climbed from the yaw deck into the nacelle. They are designed to sway, similar to a tree swaying in the wind. We do have a wind speed limit of 18 metres a second when we're up here. Should the wind speeds be in excess of 18 metres a second, we'll do what work we can do further down the tower. Behind me and behind the wall that you can see are the 3 45-metre length blades, which are connected to the hub, and the hub in turn is connected to the low-speed shaft, which turns the rotor, creating electricity through the generator. Each blade can be turned into and out of the wind individually. If you see the turbines operate from a stop, you'll see the angle of the blades change, creating lift, which turns the hub.
The blades turn slowly. At SEMA, the blades rotate roughly once every 3 seconds. That's 20 rotations per minute. Typically, the larger the turbine, the slower the blade speed. The job of the gearbox is to speed up the rotation produced by the blades to the speed needed to power the generator.
This is transmitted through the yaw deck, down to the control deck, through the converters and into the base of the tower where we started our journey.
The turbines at SEMA are complex machines with thousands of parts, powerful control computers and management software. They are machines that literally generate electricity out of thin air. They produce sustainable power without gas emissions and can be quickly decommissioned at the end of their life, leaving minimal legacy for future generations.
Wind energy has come a long way in the last 10 years. It now contributes significant amounts of power to the UK. Clean, green electricity to power homes, businesses and enterprises throughout the land. Infinis would like to thank the people of SEMA and Hilton for sharing their community with SEMA Wind Farm. We hope that the wind farm is now seen as part of the community, and the people of SEMA and Hilton can be proud of the role that their community is playing, making sure that Teesside is a green and pleasant land.